All right, we're going to start with question 11. How long? So when it says how long, that means I want to find the time. Will it take an object to move 100 meters? So when I'm reading this, I should say, okay, this is t, this is x, and then this is the speed, which is v. So for number 11, whoops, I'm given x is 100 meters, v is equal to 0.5 meters per second, and I want to find t. So the basic physics equation is v is x over t. Speed is distance over time. Now, I'm not solving for v, so I'm going to rearrange the equation to solve for the unknown in terms of the known. So I'll multiply both sides. Vt is equal to x. So then t is equal to x over v. So it's 100 meters over 0.5 meters per second. So 100 divided by 0.5 is 200 seconds. So the answer is A. Number 12. So as I'm reading the problem, I can write on the test. So a car having an initial speed, so this is VI, is uniformly brought to rest. So that means VF is 0. That's one of my hidden variables because it's brought to rest in 4 seconds, which is the time. So the time is 4 seconds, and the initial speed is 16. How far? So I want to find x. So this is, so I say which equation has these 4 variables, x, vi, vf, and t. So that's the equation. X is equal to vf plus vi over 2 times t. So it's going to be 0 plus 16 over 2 times 4. So 16 divided by 2 is 8 times 4 is 32. Okay, number 3. A runner completed the 100-meter dash, so that's x, in 100 seconds, that's t. What's her average speed? So x is 100 meters. T is equal to 10 seconds. Speed is distance over time. So 100 meters over 10 seconds is 10 meters per second. All right. Number 14 says a car is traveling at an average speed. Okay, so this is my speed, V, 60 kilometers per hour. How long? So I want to find the time. Does it take to travel 12 kilometers? So on this one, I don't have to bother canceling because I see the answers in hours. So again, I know that speed is distance over time. So time is equal to x over v. So 12 kilometers divided by 60 kilometers per hour. And 1 over an hour is an hour. So 12 divided by 60 is 0.2 hours. So we did 11, 12, 13, 14, 15. An object starts from rest. So again, that's a hidden variable. The initial velocity is 0. It accelerates uniformly down an incline. If the object reaches the speed of 40, so the final velocity is 40 meters per second in 5 seconds, so the time is 5 seconds, what is its average speed? So again, the way we find averages, the average is again the initial plus the final over 2. And a little line over that means average. So 40 plus 0 over 2 is 20. So 12 was A. 13 was B. 14 was A. 15 we just found was 20. Let's see. All right, number 16. A truck with an initial velocity of 12, so VI, the initial velocity is 12, accelerates uniformly, so that's my acceleration, 2 meters per second squared for 3 seconds, and that's my time. What is the total distance? I want to find x. So now I say which equation has those 4 variables, VI, A, T, and x. So that's the equation x is VIT plus 1/2 AT squared. So I substitute in my values. So x is equal to 12 meters per second times 3 seconds plus 1/2 2 off the screen times 3 seconds squared. So when I put all that in my calculator, 12 times 3 is 36. 3 squared is 9, and then the 1/2 and the 2 cancel, so I don't even need a calculator. So it's 45. All right, so number 16 is D. Number 17, which is constant for a free-falling object? So that's the acceleration due to gravity. So number 17 is D. All right, number 18. As a body falls freely near the surface of the earth, its acceleration remains the same because it's the acceleration due to gravity, little g. Number 19, the distance versus time graph represents the motion of a laboratory cart. According to graph, the cart is. So what you have to know, and this is what you have to write down, is on a distance versus time graph, the slope is the speed. So this is a straight line, which means it's a constant slope. So that means it's moving at a constant speed. All right, number 20. The uniform motion of the cart is shown in the distance versus time graph below. What is the average speed? So again, what is the physics I need to know? That the slope is the speed because this is a distance versus time graph. So what is the average speed? Well, I would take the slope. The easiest way is to do the endpoint. So the slope is y2 minus y1 over x2 minus x1. So 10 minus 0 over 5 minus 0, so 10 divided by 5 is 2. So the answer is B. All right, number 21. The diagram below represents two concurrent. Concurrent means acting on the same point at the same time. So this is now chapter 4. Or this is chapter 3 vectors. Which vector best represents the resultant? So there's one rule for adding vectors. Vectors are added head to tail. These are not head to tail. Those are tail to tail. So how do I do it? It doesn't matter. I'll draw the top one first. From the head of that vector, I do the tail of the other. From where I start to where I end is is my resultant. So now I say which one looks like that? This one. What if I did it the other way? What if I drew this one first, and then from the head of this vector, I did the tail of the other? You see that my resultant is going to be the same length and in the same direction. So vectors are added head to tail. That's tail to tail. So, and you just don't do that. You have to redraw them head to tail. All right, let's look at number 22. So number 22 says a plane flies 400 kilometers east. So that's my south. So first of all, we need to know our geographical directions. So I have north, south, east, and west. So if I'm flying 400 kilometers south, I just start somewhere, that's 400. Then 300 kilometers east. So from the head of that vector, I do the tail of the other. From where I start to where I end up is my resultant. This is a 3, 4, 5 triangle, so I don't even need a calculator. So I know that this is just 500 kilometers. So that's my answer here, which is B. Number 23, 100 Newton force acts on point P. What's the magnitude of the vertical component? So again, this is my vector here. Every vector can be broken up into horizontal and vertical components. This is where I start. And then I go like this because components are perpendicular. So basically I have a right triangle. Okay. So the vertical component, this is the vertical. And do I use sine, cosine, or tangent? Well, this is opposite, so that's going to be sine. So sine of theta is opposite over hypotenuse. So sine of 30 degrees is opposite, which is my vertical, over my hypotenuse, which is 100 newtons. So now I kind of rearrange that and say vertical is equal to 100 times sine of 30. So on my calculator, I press 30 sine times 100 comes out to be 50. So the answer is going to be 50 newtons, which is choice B. Number 24, scalar is to vector. So a scalar quantity is speed, displacement no, and speed. To vector, this is a vector quantity, this is not. So the answer is A. 25. A baseball player throws a ball horizontally. Which statement best describes the ball motion after it's thrown? So if the ball is being thrown horizontally, like this, it's going to end up going like that. We know that the horizontal, we know that AX is 0. There's no horizontal acceleration. The only acceleration acting on this is the acceleration due to gravity. So as the ball goes down, and it looks like this, okay? If we look at the horizontal and vertical components of that, we know that because AX is 0, VX is constant. Here, there is no vertical component, but as it goes down, the vertical component is increasing. So what's happening is the horizontal component is constant, and then the vertical component is increasing, really in the negative direction, but it's increasing. So the answer to number 25 is D, its vertical speed, and it says speed because velocity would mean the direction. So its vertical speed increases and its horizontal speed remains the same because it's constant. So the answer is D. And there's pictures of this in the notes. The path of a projectile fired at 30 degrees angle is best described as parabolic. Okay, number 27. A projectile with a mass m is fired with an initial horizontal velocity vx from a height h above level ground. Which change would have resulted in a greater time flight for the projectile? So if you look at a projectile and it has a horizontal velocity like this, and it's a certain height above the ground, if we look at the equation for this, we know that t is equal to the square root of 2h over z. So as h increases, t increases as well. How did I get this equation? I got this equation from using my equations for projectile motion. Okay, so for projectile motion, this y is equal to VIYT plus 1/2 GT squared. VIY is 0 because it's all x, so this goes to 0. So y is 1/2 GT squared. And when I rearrange the equation to solve for the unknown in terms of the known, I would multiply both sides by 2, divide both sides by g, and then take the square root of both sides, and that's how I end up getting that equation. So the answer to number 27 is D. Because I have to look at this equation, and I see that as h increases, t is going to increase. So which one of these scenarios is going to cause that? And the answer is going to be D. So I just have to look at the equation for that. All right, 28. The diagram below represents the path of an object after it was thrown. Okay. What happens to the object's acceleration as it travels from A to B? Well, this is a projectile. The only acceleration acting on it is the acceleration due to gravity, which that always stays the same. All right, 29. A projectile is launched at an angle of 60 degrees above the horizontal. Compared to the vertical component of the initial velocity, the vertical component of the projectile's velocity when it reaches maximum height is. So if I look at it, here's my projectile at 60 degrees. This is the path, like this. This is what it's going to look like here. So at this point, it has both a horizontal and vertical component. If I drew the components of it like this, at this point, at the top of the path, it's all horizontal. It has no vertical component, so that's why it's going to be less. So the answer to number 29 is A. All right, 30. It says base your answers to the following question on the diagram. So someone's kicking a ball. This is the velocity, and that's the angle. So what's the horizontal component? So if I just drew it to the side, here's my velocity vector. This is 5. This is my horizontal. This is my vertical. This is 30 degrees. So I have a right triangle, and I just want to find this side. So this is adjacent, so that's how I know I use cosine. Cosine theta is adjacent over hypotenuse. So cosine of 30 degrees is equal to x over 5. So x is equal to 5 times cosine of 30 degrees. Whoops. So now on my calculator, 30 cosine times 5 is 4.3, which is B. All right, number 31. Which card has the greatest inertia? Okay, so inertia and mass are directly proportional. The greater the mass, the greater the inertia. So the answer is going to be the one with the greatest mass, which is the 4 kilogram, which is D. All right, number 32. This is just like our hoop lab. Base your answer to the following question. So when the index card is quickly pulled away from the glass, this falls straight down. So this is just like our hoop lab, which is inertia, which is an object at rest stays at rest, just like the nut falling in the glass bottle. All right, number 33. So now we're doing forces. We're up to chapter 4. So it says the two forces F1 and F2 are applied to a block. What's the acceleration? So Newton's second law says that F net is equal to ma. So the net force, I have 12 going to the left and 2 going to the right. So it doesn't matter which way you do it, because they just want to know the mass of the block. It's actually negative 12 plus 2 is going to be negative 10 is my net force. So M is equal to F over A. So negative 10 over the acceleration, which is 2, would be 5 kilograms. So the answer is B. Number 34. A man weighs 900 newtons standing on a scale in a stationary elevator. If some time later the reading on the scale is 1200 newtons, so if I say F net is equal to ma, if I had a free body diagram of somebody in an elevator, okay, it shows all the forces acting on him. So if he is in the elevator, he has his weight acting down, which they already told me is 900. And then their normal force acts up. If it's not moving, the reading on the scale is really the normal force. That's the key to these problems. So when I sum forces and I say F net, and this is 34, and we're using the same thing, is equal to ma, it says now that the reading on the scale reads 1200. So the net force would be 1200 minus 900 is ma. So 300 is equal to ma. So because this is positive, that means he's moving up. So the answer to number 34 is C, constant acceleration moving up. He's not moving at a constant speed, because if he's moving at a constant speed, there's not another force, okay? So when you're moving at a constant speed, the reading on the scale is going to be exactly the same as if it's not moving. So you're going to cross these off. If he was moving down, this would be I would have a negative acceleration, which I'm not getting. All right, number 35. The net force, if the net force acting on an object is doubled, the acceleration. So for number 35, see if I can line this up. I know F net is equal to MA, okay? So if this is 2F, it's then going to be 2A times M, and they're directly proportional. So the answer to number 35 is B doubled. Number 36, a student is standing in an elevator that is accelerating downward. The force the student exerts on the floor, that's of the elevator, must be, so if the elevator is accelerating down, then he's gonna weigh less than he does at rest. If it's accelerating up and it's positive, he's gonna weigh more. And again, it has to do with that elevator problem that I did before. If I looked at the same thing, which would be the same free body diagram, here's my weight, here's my normal force, now it's going down. So I would say summation of F net is equal to MA, so FG minus F of N is equal to MA. So FG minus MA is Fn. So now this is his normal weight. So because I'm subtracting the mass and the acceleration's down, that's why he's going to weigh less, because the normal force is the reading on the scale. So number 36 is A. Number 37, a mosquito flying over a highway strikes the windshield of a moving truck. Compared to the magnitude of the force of the truck on the mosquito during the collision, the magnitude of the force of the mosquito on the truss. So this is, again, Newton's third law. For every action, there's an equal and opposite reaction, so it's the same. All right, 38. The graph shows the graph shows the weight of 3 objects on planet X as a function of their mass, the acceleration due to gravity. So this is the weight versus the mass. So the weight over the mass. So what equation is this? Well, this obviously is the weight, F of G is mg. So this is little g. So I just find the slope. So I would pick this point and this point because it's like where it crosses. So 300 minus 0 minus 50 minus 0. And 300 divided by 50 is 6. So that's the acceleration due to gravity, B. All right, number 39. The diagram below represents a box shown sliding down an inclined plane. Toward which point is the force of friction? So if it's moving this way, friction always acts in the opposite direction. So if it's moving parallel to the surfaces in contact, friction's going up the incline, which is B. Number 40, the diagram below shows a granite block being slid at a constant speed across a horizontal floor by a force parallel to the floor. Which of the quantities could be used to determine the coefficient of friction? So the coefficient of friction, mu, is equal to F of F over F of N. So that's just the equation, which is D. Don't even have to calculate anything. So that's up to question number 40, 11 through 40 on the semester exam.